In this problem, we're going to be converting the equation 2x minus 3y equals 4 to its polar or trigonometric form. The first thing that you need to remember when converting a rectangular form equation, or what we know as an xy coordinate plane equation, to its polar form, is that x is equal to r cosine theta in the polar plane, and y is equal to r sine of theta. So using these two equations, we can substitute in our values for x and y into this equation to get 2 times x is r cosine theta minus 3 times y is r sine theta is equal to 4. And with multiplying this out to simplify it a bit, we get 2r cosine theta minus 3r sine theta is equal to 4. Whenever we're getting one of these equations in its polar form, we always want to solve for x in terms of theta. So just like whenever you're solving a standard rectangular equation, like y minus x equals 2, you always want to get y alone. So you get y equals x plus 2 when you add x to each side. The same thing is true here. We want to get r alone and move everything else to the other side. So, in order to get r alone, we need to take these two r's that we currently have and convert them into one r. And the way that we can do that is by factoring an r from each of these terms. That'll change 2 into 1, giving us r times 2 cosine theta when we divide each term by r because we factored it out, minus 3 sine of theta is equal to 4. And now finally from here we want to divide each side by the term being multiplied to our r, which gives us 2 cosine theta minus 3 sine theta in our denominator, and then the same thing on the other side. And now this 2 cosine theta minus 3 sine theta will cancel from the numerator and denominator, leaving us with r equals 4 over 2 cosine theta minus 3 sine theta. And this is the polar form of the equation 2x minus 3y equals 4.